Hi, I'm Daniel. I'd like to talk to you about Git best practices. For hardware engineers new to revision control, committing early and often can feel unnatural. Some engineers love the structure, while others feel it adds friction. That's normal and why commit practices should be flexible but powerful. This chapter outlines the good, the bad, and the ugly committing changes, with an emphasis on clarity, traceability, and reducing downstream errors. In a Git-based workflow, or any workflow, users make changes to one or more files and then commit those changes to their local repo. When ready, they push the commits to a remote branch. Initially, assume a single user is working without needing to pull remote changes. This keeps things simple. Commit best practices. Commit to the right branch the first time. One of the easiest ways to prevent Git issues is to commit to the correct branch. Mistakes in branching can quickly spiral into difficult to resolve merge problems, especially with ECAD files. Why does it matter? Misbranded commits can introduce errors into the wrong revision. Manual recovery of hardware files is tedious and error-prone. Copy-pasting ECAD content often leads to bugs, deleted features, or broken nets. Fixing mistakes in Git is possible, but risky. Avoid unnecessary rework and confusion by branching correctly from the start. 2. Commit-related changes. Group changes logically. Unlike software, hardware design is massively parallel. Circuits aren't small functions split into files. Instead, the related changes can span many components and interconnects. Make small, focused commits when possible. Label every net on the main microcontroller U47, or connect all the open nets on ADC U17. Log your work in progress, even if it's unfinished. Place block diagrams of a relay control circuit, or add all the PMU ICs unconnected. Doesn't matter. It's better to get them into the system. Use batch commits for broad updates. Add voltage regulators to library, or change all the load resistors to 1K, or connect all the I2C nets. Or fine-tune over time. If you spot unrelated issues while working, jot them down into an issues.txt file or create a Git issue instead of fixing them mid-task. Strive for coherency in each commit, but don't let perfection block progress. Commit often, perfect later. Capture partial progress. It's better to commit a half-right circuit than block yourself waiting for a perfect version. Use stand-ins, i.e. generic resistors, to capture topology early. Keep track of known issues. Leave notes like, to do, update resistor values to match reference design, or track the changes in an issue. Smaller commits are bigger than big commits. Dozens of smaller commits are easier to manage than one massive catch-all commit. If unsure how often to commit, talk with your team to set expectations. Use commits as rollback points. Before replacing components, rerouting traces, or tearing up a layout section, commit first. You've got a snapshot. Test your designs before you commit. Run DRC checks. If your EDA tool provides design rule checks, DRC, or logs, run them before committing. Even if the design isn't error-free, capturing the log helps trace when errors were introduced. Track error files for diffing. Including error logs in your project surfaces regressions and supports CI/CD processes. Use simulations selectively. Spice and other tools can catch bugs, but they can be brittle. Use short simulations often and long simulations periodically. Capture your simulation results. For EMI, high-speed, or antenna-related tests, tracking results helps correlate layout changes with performance regressions. Write good commit messages. Be clear and concise. Commit messages should describe what changed and why. Stakeholders should grasp the scope at a glance. Aim for less than 50 characters, 72 max. Summarize the main change. Don't try to include everything, 50 characters. Add a blank line and then include a longer description if needed. Good examples. Add a voltage translator to the I2C nets. Replace op-amp with higher bandwidth active 1378. Fix noise issue on dithering circuit. Avoid vague messages like fixed bug with Y or changing behavior of X. It's not clear enough. Use the imperative mood. This isn't entirely essential, but it is the idiom of Git. So write commits like commands, not history. Think if applied, this commit will. Connect a DAC to an amplifier circuit. Add resistors to the transistor network. So this is a more common usage, is connected DAC to amp. A lot of people will use the past tense. The imperative mood is the preferred mood, but honestly, as long as you get your commits into the system, it's better than nothing. While your team may prefer another style, the imperative phrasing keeps commits consistent and easier to scan in merge workflows. Summary: good commits equal good hardware. Follow these simple principles. Commit small, related changes. Use clear, structured messages. Run tests and DRC before committing. Track errors and simulation results. Use the imperative mood for clarity. When merging and releasing, these habits reduce review overhead, help identify bugs faster, and make the team collaboration smoother. Start simply, commit early, commit often, and commit clearly.
Thank you so much for joining us. If you haven't already, I would like you to click the like, subscribe, notification bell, any of those things. If you have a question about Allspice, or if you just have a really excited idea, drop down into the comments. I'd love to hear from you. We've got webinars, we've got ebooks, and we also have the next chapter of this video series coming up. So I'll see you later on the internet.